Alright, so this video we're going to look at finding the cross product of two vectors. Alright, so if we want to find the cross product of vectors A and B, all it is equal to the determinant. Okay, where vector A would equal A1, A2, A3, and vector B would equal B1, B2, and B3. Okay. All right. So whenever we do the cross product and we calculate this determinant here, all it is to do the determinant, we will delete the first row. Okay. And then we will delete each column. So first, let's go ahead and take away the first column. So the dot product would be this, the determinant of this 2 by 2 here. So that would be the determinant of A2, A3, B2, B3 times, you see where they cross here, when I cross out the row and cross out the column, they intersect here, so that's times vector I. And then it's minus, the signs are going to alternate. Okay, all this is just finding the determinant of a 3 by 3 matrix. Okay, you should know how to do it. All right, so once again we've got the first row crossed out, and then I cross out the second column, and then you see this 2 by 2. All right, so it's the determinant of that, which is A1, A3, B1, B3, the determinant of that, times vector J. And then plus, remember the signs alternate, plus, minus, plus. Okay. And so if we cross out the third column, then we have the determinant of this 2 by 2. So that's going to be A1, A2, B1, B2 times vector K. All right. Now, do you remember how to find the determinant of a 2 by 2? Okay. Remember, it's just this times this minus this times this. You multiply the diagonals and you subtract them. So that's going to be A2 times B3 minus A3 times B2 times vector I, minus A1 times B3 minus A3 times B1 times vector J, plus A1 times B2 minus A2 times B1 times vector K. And this would be your cross product here. All right, so don't try to memorize the formula, just know the procedure. That's why I went ahead and worked it out for you, and with just variables in there. All right, so let's look at our example. We want to find the cross product of A and B and verify that it is orthogonal to vectors A and B. So we want to verify that the cross product is orthogonal to the two vectors A and B. Well, there is a theorem that says that the cross product of A and B is orthogonal to both vectors A and B. Okay, so there's a theorem that states that. So we have to we're going to find the cross product, and we know once we find the cross product that cross product will be orthogonal to vectors A and B, but we're going to show it. Okay, and I'll explain how to show it when we get to that step. All right, so let's go ahead and calculate the cross product. So the cross product of A and B is equal to, and that's going to be the determinant vector I, vector j, vector k. And then remember, vector A goes on the second row, and so that's going to be 1, 3, negative 2. It's just the coefficients in front of the vectors, the 1, 3, and negative 2. And then this row is going to be vector B. So I, that's negative 1. The number in front of vector K is 5. Now notice there's no vector J there, so that would be 0. Okay. All right, so let's calculate this determinant here. So first, we're going to cross out the first row, and we'll also cross out the first column. So that's going to be the determinant of this 2 by 2. So let's go ahead and write it like this. Let's write it out. That's going to be 3, negative 2, 0, 5 times vector I minus, remember the signs alternate. Whoop. Alright, so now let's do away with the second column. So that's going to be the determinant of this 2 by 2. So 1, negative 2, negative 1, 5 times vector j plus, now let's take out the third column. So that's going to be the determinant of this, which is 1, 3, negative 1, 0 times vector k. Right. So now let's calculate the determinants here. So we've got 3 times 5, so that's 15, minus negative 2 times 0 is 0, times vector I, minus, all right, so now we've got 1 times 5 is 5, minus negative 2 times negative 1 is 2, positive 2. All right, so that's times vector j plus, whoop, all right, so plus, so I've got 1 times 0 is 0, minus 3 times negative 1 is negative 3, times vector k. And so this is going to give us 15I minus 3j plus, and then that's going to be 3k. So this is the cross product of A and B. All right. Now what they want us to do is verify that this is orthogonal to both vectors A and B. All right, so I'm going to erase this so we'll have some room up here. I'm going to work it up there. All right, so let's look at this. Let's show that the cross product, which is, this is your cross product. Okay, so let's show that this cross product is orthogonal to vectors A and B. All right, so how do we show that they're orthogonal? Well, that means their dot products are 0. So if I do the dot product, okay, so I've got the cross product of A and B, and I do the dot product with vector A. Okay, so what we have here, if we write these as a vector, that is going to be 15, negative 3, 3, dot 1, 3, negative 2. Okay, so remember how to do the dot product. So 15 times 1 plus negative 3 times 3, okay, negative 3 times 3 plus 3 times negative 2. And you can see that's going to be 15 minus 9 minus 6, which is 0. Okay, so that shows that it's orthogonal to A. And since we're up here on time, I'm not going to do B. It would be the same thing. You would have the 15, negative 3, 3, and do the dot product with B, which would be negative 1, 0, and 5. Okay. I guess we'll go ahead and do it now. Alright, so that's going to be 15 times negative 1 plus negative 3 times 0 plus 3 times 5, and you can see that gives us negative 15 plus 15, which equals 0. So there we verified that it's orthogonal to both. Alright, so I hope this video helped. Check out my other videos. I got a lot of other calculus videos, and I'm going to be putting more up. So give me a like, share, subscribe, and thanks for watching.